Welcome to VK's Coding. So in this video, we'll talk about what is microservices, what is monolithic architecture, and when we deploy the new microservices, like what will be the phases and what are the architecture pattern is available for designing those different phases. So without a delay, let's get started. So what is monolithic architecture? So basically in the monolithic architecture, there will be one machine and there will be a single code base which will be responsible for every modules, right? So suppose if you take e-commerce application, then it is this single machine and the single instance of the application will take care of the product management, order, payment, and everything. So basically, client browser will interact to the single application, this single instance of that particular application, and this application will interact to the single DB, and it will perform all the jobs. So there will be all the business logic, presentation layer, session layer, service layer, everything will be deployed in a single instance. So this is nothing but the monolithic architecture. So let's proceed further and check further what is advantage and disadvantage of the monolithic architecture. So easy to develop because the application is built in the one code base. So there will be only single code base. So it is very easy to develop. And development is easy because there will be one executable file, right? So there will be deployment is very easy to deploy that particular SAR or WAR or whatever the executable file is present for the application. And the basically the API performance will be better compared to the microservices in the monolithic architecture, because suppose we have a microservice architecture, then we have to get if we are calling one API, then this API is calling multiple microservices to return the response. But in monolithic architecture, there will be only one application is running and it will return the response. Comparing to the API response, so monolithic architecture having the better performance. So the fourth point is saying debugging is easy because there is a single code base, so we can easily debug. And testing is also very easy. There will be one instance of that particular application is running, so end-to-end testing can be performed compared to the microservice architecture. Because in microservice we have a different services running. In monolithic there will be one services running, so it will be very easy to test, right? But what are the disadvantages of the monolithic architecture, right? So in the monolithic architecture, over a time, right? So when we write a lot of code in a monolithic architecture, because it involves everything, business layer, DAO layer, say service layer, everything it is there in the single code base. So over a time, the code base will increase, and it will very difficult to manage. And if you load in the id will become very slow, right? And even the new developer joins to the team, it will be for him it will be very complex to understand the full architecture of the application, and to manage that particular project is very difficult. So that is the first point it says. And the second point is saying individual component can't be scaled because everything is packed in a single machine, right? So it cannot be scaled individual component. And even there is a error in one module, suppose there is a error in the first module, it will affect the other module as well. And even if any framework changes is required, suppose in this module we wanted to adopt a new framework, that cannot be possible because it can affect the other module. And sometimes what happens if one module having some issue, it can means break the whole application, and it can shut down the whole application. So these are the disadvantages of the monolithic architecture. So in the microservice architecture, there will be a small services. Like for a bigger application, we divide in the small services, like and each having the different set of capabilities of doing work. Like this product management is responsible for product management service, order management service is responsible for order management service, payment microservice is responsible for payment management. So these three different services are performing the different business capability or different roles and responsibility, and they all over communicate over the HTTP protocol. So so we can use the RESTful services for the communication, or we can use the event based or messaging like Apache Kafka or RabbitMQ. Anything can be used for communication between the microservices. So what is microservices? Microservices in nothing but a small services which communicate each other. That is nothing but the microservices. So what are the advantages and disadvantages of this approach while designing the microservice architecture of application? So let's check further. So first we are checking the advantages. So managing component is very easy because each component is kind of a single responsibility principle kind of thing. Like one microservice is responsible for only for order management, and another microservice is responsible only for payment management. So each microservice which perform their some set of business capability they provided. So managing each component because they are performing separate tasks, so it will become very easy. And second point is, say if one service having the changes, like order service having the some changes, then we have to redeploy only the order services, not the whole microservice. All the microservices we don't have to redeploy it. And individual microservice can be easily scaled. Suppose if you want to scale the order service, we are getting so many orders, then we can horizontally scale this order service, order 1, order 2, order 3. These services we can easily horizontally scale it. And suppose there is a bug in the order service, then it won't affect the payment microservice. So this is also a good benefit over the monolithic architecture. And the next one will be the each microservice can use the different technology. Developing the small set of one small microservice will not take a much time, and they all communicate over the HTTP. So there will be JSON request response or messaging can be done between the microservices, and developing the small service will not take a much time compared to the monolithic one. Where in the monolithic we cannot adapt a new technology because that framework and the technology will affect the existing code base. Here we can implement those new technology in a new microservices, so it will not affect the other microservices. Even the existing microservices also we can implement it, so it will not affect the another microservices. So compared to the monolithic, these are the advantages of the microservice architecture. But in the microservices architecture also having some disadvantages as well. So what is the first disadvantage is, if we don't decompose properly, right, then latency can be increased. So what I meant here, suppose you are making some call to the one microservices that is calling to the second microservice, and that is going to calling to the third microservice, and then it will returning the response. So this call is going to three microservices. So if the architecture is not done properly, then latency can increase, right? And debugging also can be become difficult because the control flows between the many microservices like S1, S2, S3, S4, like calls are going from all these microservices. So while if you debug, so you have to trace it all the microservices and check where is the problem and all. And transaction management is also difficult in the microservice architecture, because in some of the requirement, like if all the microservices having the separate DB, and if there is a some requirement is coming, you have to make a atomic transaction between all these three database. Then you have to lock all these three DB. Then you have to perform the read or write operation to these DB. So locking is these DB all three together and writing it something become very difficult in the microservices architecture. But we have a option solution available for these problems in a microservice architecture. And next problem is, suppose a new change is deployed to the third microservices, then it can break the microservices of S1 or S2. Suppose S1 is calling to S2, S2 is calling to S3, and some new code changes made in the S3, then S3, suppose S3 is down, now S2 is also broken and S1 is also broken, because these S1, S2 both are dependent on S3. So this is all about the monolithic architecture and the microservice architecture. Now, when we deploy a new microservice architecture, right? So we have to know, like when we say microservices architecture, then how much small that microservice could be. There should be some architecture design pattern or some guidelines should be available to adhere that while designing the our microservices. So definitely it is available, and everything phase by phase it is available, and each phase we having a lot of options in that. So we'll explore each phase and what are the option available on those phases. So first we'll go with the decomposition phase. So first one is a decomposition phase. So decomposition phase says that how to break your bigger application into the normal small microservices, or like how to develop a small microservices. So based on the business capability, suppose you want to develop a online e-commerce applications, right? So it can have a different business capability like order management, login service, payment service, delivery management service, and other service can be also possible, right? So for each business capability we'll design the separate microservices. So there will be this is the first approach in the decomposition phase, and the second one is decomposed by the subdomain. It means suppose one domain is a order management, then within the order management there could be a order placing microservice, first one. Second one will be order tracking microservice. Third one will be the order history maintaining the for that microservice. So this is how in the decomposition phase how we can design our microservices based on business capability and the based on the subdomain. The now once we are able to identify like how to divide our microservices, now next phase is to choose our database. So next, let's see the next phase what it is. So next phase is the database phase. So in database phase we have a two approach: a database per microservice. So basically for per microservice, microservice M1 will have their own database, microservice M2 will have their own database, microservice F3 is having their own database. So database per service is the first approach in the database, and the second approach is this shared database. Suppose you have a microservice M1, M2 and L3, then all will be sharing the shared database, one database only. So in the database approach, we have a two option, database per service wise and this ADB can be used. Next phase is the communication phase. In the communication phase, there could be a synchronous communication and the asynchronous communication. So basically in the synchronous communication, what happens? Client send a request using HTTP protocol and wait for the response from the service. And the client has blocked the thread while waiting for the response. Suppose this product microservice is calling for the order microservices. So here basically the thread actually it is waiting. It is in waiting state until unless it get the response from the order microservices, and once it got the response it can resume the execution. And synchronous communication, how it can be done over the http, it is http protocol, we can use the restful web services. And for asynchronous communication, so basically when the client send the request, it does not wait for the response from the services, and the client thread also it is not blocked. So it means when the thread is executing, it is making a call to the another service, it can resume the its execution. So in the, how we can implement the asynchronous communication, so definitely we can use the messaging like product microservice will put one message to the queue, and from the queue the order microservice will take it from the queue, that particular message, and if he want to pass some messages to the payment service, then he can put that message, particular message into the queue, and the payment service will take the message from the queue. So this is how the communication is done in the asynchronous way. And for messaging, Kafka, Apache Kafka, RabbitMQ can be used. And for synchronous communication, the RESTful web services can be used. So this is all about the communication style for the microservices. So let's proceed further and check the next phases. So in the next phase is the integration phase, like basically how the UI can interact with the microservices. So basically how the external API communicate to our microservices, right? So for that there will be a single entry point for application. So basically there will be a API gateway. So for the UI, it will come to the API gateway, or if anybody is calling the public API, right? If any third party application is calling the public API for our microservices, then it will go through first the API gateway. We have to implement it, and API gateway could be the Netflix API gateway, and this API, all the requests come through the API gateway. Then it will go through the microservice, all the microservices. So basically, the API gateway is front controller kind of role it will play here in the integration phase, and Netflix API gateway can be used in the integration phase. Let's check the next phase. What will be the next phase is? So next phase is the deployment phase. So we have decomposed our microservices, we have chosen the database, we have chosen the what are the communication we have to use, and the integration, how to do that we have also seen it. Now we have to see for deployment, how we gonna deploy that particular microservice. So first one is the multiple services instance per host. Basically there will be a one physical server, and we can deploy a different JVM process for each service. S1 will have a separate JVM process, and S2 will have a separate JVM process, and S3 will have a separate JVM process. But all this JVM process running in a physical server. So this is what we are calling here multiple service instance running per host. And the second option we have is the each services we have a particular host. So service one is running in the host one, and service two is running in the host two, service three is running in the host three. And now another option we have to run as a all services running as a different container. So basically container is what is happening. Basically it's a Docker image that will run as a Kubernetes pod in the Kubernetes namespace. Suppose it's NS is the namespace, then where there will be a different pods which is running as a container inside the Kubernetes environment. And the another approach of the deployment is a separate virtual machine. So what is the virtual machine? So there will be a hypervisor. Basically, there will be a one host machine, and on top of that, we install some software. So that will virtualize the environment. On top of that, we can create a virtual mini virtual machines, and each services will be deployed in those virtual machines. So these are the deployment strategy. Anyone can be used for deploying the our microservices. And so this is are the related to the deployment. So now we are done with the deployment. Now it's close to 18 minutes. So there will be a lot to cover, but I just wanted to give a one or two line in observability and reliability. So basically in observability, we have to check for the logging, like how to do the logging, because the request will flow from the many microservices, right? Microservice S1 to go to S2, and it will go to S3. So how the logging can be performed? So basically we have to build a correlation ID. So S1 will add some ID, then S2 will add some ID on that particular request, and S3 can add some ID. So we can build a correlation ID, and for analytics we can use a centralized logging and all. So those things will come as part of the observability. And the next phase is the reliability. Basically it's a kind of fallback mechanism. Suppose S1 microservices is calling to the S2 service, and S2 service is down for is down, then S1 will call for a request, and it will wait for like 10 seconds. And if it not getting a request, then it will get timeout, and we can implement here a circuit breaker. So once the request is timeout, the request will be moved to another service or whatever the fallback mechanism we have implemented here. So this is all about the microservice architecture and why we have moved from my monolithic to microservices architecture. So there will be a lot to cover in this. So I'll create a separate video on those important topics. So please do subscribe my channel to get to know more about the system design interview topics.